Our Earth holds a lot of ice. This ice exists in many different forms and places. We see glaciers like slow-moving rivers of solid ice in high mountain ranges across the globe. Think of the majestic Alps, the towering Himalayas, or the rugged Andes. These glaciers have been present for thousands, even millions of years. They are not just beautiful to look at, they are also vital. They store vast amounts of fresh water, which feeds rivers that sustain communities and ecosystems downstream. Their slow melt provides a steady water supply during dry seasons for many regions. Beyond mountain glaciers, there are enormous ice sheets. These colossal expanses of ice cover huge land areas. Greenland, in the Arctic, is almost entirely buried under a massive ice sheet. In the southern hemisphere, the continent of Antarctica is covered by an even larger one. These polar ice caps are incredibly thick. In some places, the ice is several kilometers deep. Together, they contain the vast majority of all fresh water on our planet. Scientists drill into this ancient ice, extracting ice cores that provide a frozen record of Earth's past climate conditions. This ice plays a crucial role in regulating Earth's temperature. Ice is very white and highly reflective. When sunlight hits these icy surfaces, a large portion of it is reflected directly back into space. This phenomenon is known as the albedo effect. It helps to keep our planet cooler than it would otherwise be. The ice acts like a giant, natural mirror, preventing Earth from absorbing too much solar radiation. This cooling mechanism is essential for maintaining stable global temperatures and climate patterns that we are accustomed to. Without it, our world would be a much warmer place. Unfortunately, our planet is currently experiencing a significant warming trend. This global warming is causing the Earth's ice to melt at an accelerating rate. Glaciers in mountain regions around the world are visibly shrinking. Many smaller glaciers have already disappeared entirely. The massive ice sheets in Greenland and Antarctica are also losing substantial amounts of ice each year. This melt is not a distant future concern. It is happening now. Scientists observe these changes with growing alarm, as the consequences of this widespread ice loss are profound and far-reaching for the entire planet. When ice that is situated on land melts, the resulting water eventually flows into the oceans. This process is quite straightforward. Imagine adding more water to a glass that is already partially full. The water level in the glass will inevitably rise. Our planet's oceans behave in a similar manner when meltwater from glaciers and ice sheets is added to them. More water entering the ocean basins means that global sea levels will increase. This is a direct and undeniable physical consequence of melting land-based ice. It is a fundamental principle of displacement. Scientists have made careful calculations about how much sea levels could potentially rise. If all the ice currently locked up on land were to melt completely, the impact would be dramatic. Global average sea levels could rise by an estimated 70 meters, which is approximately 230 feet. This is an enormous increase. Such a rise would fundamentally redraw the coastlines of every continent around the world. Many familiar coastal landscapes and low-lying areas would be submerged. This figure helps us understand the sheer volume of water presently stored in Earth's ice reserves. It is important to distinguish between different types of ice when considering sea level rise. Ice that is already floating in the sea, such as the Arctic sea ice cap, behaves differently. When sea ice melts, it does not cause a significant rise in sea levels. This is because floating ice already displaces its own weight in water. It is much like an ice cube melting in a glass of water. The water level in the glass does not noticeably change. However, ice located on land, such as the Greenland ice sheet or Antarctic glaciers, adds new water to the oceans when it melts, directly contributing to rising sea levels. The complete melting of all Earth's ice and the subsequent full sea level rise would not occur instantaneously. It would be a very long process, likely unfolding over centuries or even millennia. However, the rate of melting can accelerate, particularly if certain critical environmental tipping points are crossed. Once these thresholds are passed, the melting process could become much harder or even impossible to reverse. Even a relatively small amount of sea level rise, such as a few feet, can cause significant problems for coastal communities. We're already observing the initial impacts of rising seas in various locations today. The most immediate and visible consequence of significantly higher sea levels would be the inundation of coastal cities. Many of the world's largest and most economically important urban centers are situated in low-lying coastal areas. Cities like Miami, New Orleans, New York City in the United States, or international hubs such as Shanghai, Tokyo, London, Amsterdam, and Kolkata would face severe flooding. These cities are home to hundreds of millions of people. Their homes, businesses, and critical infrastructure would be threatened or entirely submerged by the encroaching waters. This presents a stark reality for urban coastal populations. The displacement of people from these flooded cities would be on an unprecedented scale. Millions, potentially billions of individuals would become climate refugees, forced to abandon their homes and seek safety elsewhere. Finding new housing, employment, and essential services for such a vast number of displaced people would be an immense global challenge. The loss of infrastructure, including ports, power plants, transportation networks, and historical landmarks, would result in staggering economic costs. The social fabric of entire nations could be disrupted by such mass migrations and the loss of established communities. The melting of vast quantities of ice also has profound effects on global climate patterns beyond just sea level rise. When enormous amounts of cold, fresh water from melting ice sheets pour into the salty oceans, it can alter ocean currents. These currents, such as the Gulf Stream, act like massive conveyor belts, transporting heat around the planet and influencing regional climates. If these currents are disrupted or weakened, it can lead to significant and unpredictable changes in weather patterns across continents. This includes shifts in temperature and precipitation. We could expect to see an increase in the frequency and intensity of extreme weather events. Some regions might experience much heavier rainfall, leading to more frequent and severe flooding. Conversely, other areas could suffer from prolonged and devastating droughts, impacting agriculture and water supplies. Powerful storms such as hurricanes and typhoons could become stronger due to warmer ocean surface temperatures and altered atmospheric conditions. Winters might become unusually cold in some areas, while summers become dangerously hot in others, making our global climate far less stable and predictable. Animals that are uniquely adapted to icy environments would face the direct loss of their essential habitats. Polar bears, for instance, rely heavily on Arctic sea ice as a platform for hunting seals, their primary food source. As the sea ice diminishes, polar bears find it increasingly difficult to hunt, leading to starvation and declining populations. Similarly, various species of penguins and seals in Antarctica depend on stable ice conditions for breeding, resting, and foraging. The disappearance of this ice would severely threaten their survival, as these species cannot easily adapt to entirely different environments. The impacts of melting ice extend far beyond these iconic polar species, affecting entire marine ecosystems. The influx of fresh water into the oceans changes water salinity. Altered ocean temperatures and disrupted currents also impact the distribution and behavior of marine life. Fish populations might shift to new, cooler areas, or their numbers could decline. Coral reefs, which are already highly sensitive to temperature changes and ocean acidification, would face additional stress. The intricate food webs within the oceans could be profoundly disturbed, with cascading consequences for global fisheries that many human populations depend upon for food and livelihoods. To prevent the catastrophic scenario of all ice melting, humanity must take decisive and collective action. The most critical step is to significantly reduce the emission of greenhouse gases into the atmosphere. These gases, primarily carbon dioxide and methane, trap heat and cause the planet to warm. They are released in large quantities when we burn fossil fuels like coal, oil, and natural gas for energy and transportation. Transitioning away from these polluting energy sources is paramount. This requires a fundamental shift in how we power our societies and industries. We must accelerate the adoption of cleaner, renewable energy sources. Solar power, generated from sunlight, and wind power, harnessed by turbines, are increasingly viable alternatives. Improving energy efficiency in our homes, businesses, and transportation systems can also make a big difference by reducing overall energy demand. International cooperation is essential. Governments worldwide need to work together to implement strong climate policies and meet emission reduction targets. Ultimately, the future of Earth's ice, and indeed our planet's climate stability, depends on the choices and actions we commit to today.